Solving System of Equations by Substitution Part 3. In the next two examples, we'll look at solving these two systems. One equation is in slope-intercept form. The other equation is in standard form. And again, based off of the first couple examples that we've watched in another video, we know that we can substitute 3x plus 2 in for y. And in doing so, we get negative 6x plus 2 times 3x plus 2 equals negative 1. And of course, we'll take the 2 here and substitute. But before we do that, we'll bring the negative 6x down. So 2 times 3x is 6x, and 2 times 2 is 4, equal to negative 1. Now, let's combine like terms. I got negative 6x plus 6x. Now, negative 6x plus 6x gives me 0. And what we're left with are just numbers. What has happened is our variables have dropped. Okay? And when your variables drop, you're left with only numbers. So let's compare what's left. 4 equal to negative 1. Does 4 equal negative 1? No. The left side of the equation does not equal the right side. This scenario happens when we have either parallel lines or the same lines, which in this case, because the left side did not equal the right side, we're left with 4 equal to negative 1. This is the case in which the variables drop. Left side does not equal right side, so therefore this is a parallel line, and we know that the answer is no solution. Okay, so when solving for systems of equations by substitution, when we run into parallel lines, we know that our variables will drop. Let me erase that real quick. We know that our variables will drop, and our left side will not equal our right side. Okay. When our left side is not equal right side, we know it's parallel line, and then the answer is no solution. Okay. So let's look at the next example. Again, we have a slope-intercept form and a standard form, and we're going to solve this by substitution. That's the way that leads the easiest to the easiest resolution. So let's look at substituting negative 5x in for y. So in doing so, we'll have negative 5x minus, I'm going ahead and putting a 1 here. There's a 1 right there, so I'm going to go ahead and put a 1 there. It's a negative 1. And then we have 5x minus 13, because that's what y is, equals 13. So we'll take and circle our number that we'll need to distribute through, but we'll bring down first negative 5x. Negative 1 times negative 5x is positive 5x, and negative 1 times 13 is positive 13. Now that's all equal to 13. Let's go ahead and combine like terms. Negative 5x and 5x is 0. So we're left with 13 equals 13. Our variables dropped, and when our variables drop, we're left with either one of two solutions, either parallel lines or the same line or coinciding lines. Now, when our variable drops, let's look at the numbers that are left. Our left side does equal our right side. In doing this, this tells us that we have the same lines, and the answer is infinite amount of solutions. Okay? And we get this when we have the same lines. If we were to graph these, we would find out that these are the same line. They touch the whole entire way. Our variables drop, meaning they go away, they cancel out. And our left side is set equal to our right, and they're equal. We found 13 equal to 13, so that means left side equals right side. In this case, it is an infinite. The answer is infinite amount of solutions. So to kind of summarize the two examples that we had, in these two examples, our variables dropped and we saw solutions that were no solution and solutions that were infinite amount of solutions. And that's all dependent upon what numbers are left and comparing those numbers. So it's very crucial to understand that you can either have solving for x and y. That means that the lines are going to intersect. When you have parallel or the same lines, you have the opportunity, or you will have the variables drop, and then you're comparing the numbers left over. This concludes part 3 of solving system of equations by substitution.